Hello grade 11s and grade 12s, welcome to my channel. Let us have a look at this question paper from KZN, June 2026. This was sent to me by one of my colleagues and I felt it has some very good questions which I think they are worth sharing. So let's have a look and see what was going on in here. So as you can see, the province and the duration of this paper. Obviously, the instructions are important, folks, especially instructions of this nature. We must always make sure we adhere to them. Now, it says we need to round off to 2 decimal places unless otherwise stated. So this is cool. Obviously, everything else applies still. Okay, a warm-up question. Question 1. So question 1. We know we're solving for x. So we've got 1.1.1. We've got minus x into x minus 3 is equal to 0. So this is already factorized, so we can already see that x is 0 or x is 3. No questions asked. But remember, folks, as a student, please run a check. Okay, please run a check. The check is such that the left hand side is equal to the right hand side when we substitute these values. If we look, if we put 0 there, the whole thing becomes 0, so this is good. If we put 3, this bracket becomes 0, so the whole thing becomes 0. So this is excellent. Please, folks, do this all the time, so that any mistakes that have happened are prevented. Now we're looking at 1.1.2, so we've got x squared minus 100 is equal to 0. This is a difference of 2 squares for those who know. So we know how to factorize this. This is x minus 10 plus 10. So we can see that x is either minus 10 or x is 10. Others can transpose the 100 and take the square root. X is going to be plus or minus 10. Nice and easy, guys. How you solve this one is fairly easy. Right, so the method here is important and the 2 solutions. Nice and easy. Again, check the solutions. As I said, don't be fooled by how everything looks so nice and easy. It's so easy to make a mistake here. Please always run a check. Check whether the left hand side is equal to the right hand side. We can check it. If we put minus 10 squared is 100. 100 minus 100 is a 0. So the left hand side is equal to the right hand side. Same here. If we put a 10, still the same result. So these solutions are good. So 1.1.3 says we need to solve correct to 2 decimal places. We already know what's happening here. So let's write 3x minus 5 is equal to 3 over x. Obviously, we multiply throughout by x, the common denominator. So this gives us 3x squared minus 5x is equal to 3. Okay. This implies that we've got 3x squared minus 5x minus 3 is equal to 0. There's no point in attempting to factorize here. X is minus b plus or minus the square root of b squared minus 4ac all divided by 2a. We know that once we have to do this, we either complete the square or we use the quadratic formula. Technically, these are just one and the same thing. So this is minus into minus 5 plus or minus the square root. Perhaps let's do it a bit better. The square root of minus 5 squared minus 4 into 3 into minus 3 all divided by 2 into 3. Therefore, x is, let's just put it on the calculator. There's no need to waste time here simplifying because, I mean, there's no mark for that. So So minus into minus 5 plus into minus 5 squared minus 4 into 3 into minus 3 all divided by 2 into 3. So this gives us our first answer as 2,14 to 2 decimal places. The second one is essentially minus 0,47. Okay, now again folks, before we settle with these solutions, ensure that at all times during practice we check that the left hand side is equal to the right hand side. Now for this one, we need to round off to the nearest integer, so to speak, or whatever it is. And remember, when we run the check, it is run on the original equation. Ensure to copy it as it is given. Do not modify it to avoid problems that can come with any modification. Now when we run this check, we're going to just substitute to the left hand side. So we've got 3 into 2,14, right, and then we subtract 5. Let's see, this gives us a 1,42. Let's check if this is going to be equal to the right hand side. So we've got 3 divided by 2,14, and we get more or less the same answer. This is 1,40, so to speak. I mean, these are not too bad. We needed to round off, so it's more or less okay. So we can accept our solution. We do the same, substitute this. So we're going to have 3 into minus 0,47 minus 5. So this gives us a minus 6,41. Let's check the right hand side. This is 3 divided by minus 0,47. Again, this gives us a minus 6,38 or whatever. So this is essentially approximately 4. So this is also appreciable. Again, if we decide, we can just round off to the nearest integer. So we will see that it's 1 is equal to 1, 6 is equal to 6, minus 6 essentially. So that solves the problem. So sometimes be very careful. If the answers seem to not want to agree, just round off to the nearest integer. Everything looks good. So we get a mark for the substitution. And we also get a mark for writing our equation in standard form. So this is how we score these 4 marks. Okay, let's get to the next one. Will we do it here? Maybe. Okay, maybe let's do it in the next page. So 1.1.3, excuse me, it cannot be 3 but 4. Right? So this is our quadratic inequality. So we've got x minus 3 into x plus 4. This is greater than and equal to 8. Now since it's not 0 on the right hand side, we need to FOIL this thing. So it's going to be x squared. 4 minus 3 is going to be plus x. Then this is minus 12. We bring in the 8. Minus 8 greater than and equal to 0. This is nice. So this also implies that we've got x squared plus x minus, this is 20, greater than and equal to 0. Great. So we can factorize our friend back. So this is x factors of 20 that can give us 1 is 4 and 5. 5 must follow the sign of the middle term. Nice and easy. So with this, folks, we can just choose the graphical method. Please, students, attempt to do a near perfect sketch, because if you don't, you're going to run into big problems, and this will be your own problem. Okay. So avoid these sketches that you guys are taught to do. They are good for quick answers, but When it comes to serious questions, this can cause problems. Obviously, our parabola is going to do stuff like this. Where is our axis of symmetry, by the way? It's going to be on the negative axis. So this is how it's going to work. Is it? Yes. It's going to be here. We tan before we cut on the y-axis. So this is the parabola that we expect. Critical value is going to be -5 and 4. And our y-intercept is -20. Of course, I'm just being silly at the moment just to cover everything. So technically, when is this greater than 0? We can already see that this is this region. And this region, all these x values to the left of our critical value are giving us what we require. So, and of course equal to 0 at those very points. So our answer is to say x must be less than and equal to -5, or x must be greater than and equal to 4. This is cool, nice and easy. So folks, we get our marks quick and very fast. So first and foremost, we get our mark for this business because it somewhat gives us the critical values, and then we can get our marks for the solutions and essentially for the distributive law that was applied here. Of course, these marks can be anywhere, but I think that's the critical step. At most 3 marks. Now for those who want to practice the table method, let me show you here, because this table can save you a lot of pain. So we take these factors x plus 5 and then x minus 4, and we place them in our table. So how we do it is like so. Now we must place our critical solutions in ascending order. So the smallest -5 and then the +1. And of course here we're doing a product. So what are we doing? We check when is the first binomial factor going to give us 0 when x is -5. Now when x is greater than -5, what does this give us? A positive answer. And obviously the other side would be negative. When is the next one going to give us 0? When x is 4. Then anything bigger than 4 gives us a positive. This side becomes negative. We do the product. Negative times negative is positive. 0 times any number is 0. Positive times negative is negative. Positive times 0 is 0. Positive times positive is positive. Now we look where our solutions at -5 is 0 included. Yes, so we shade. And then in which direction? We go in that direction of positive. Same here, 4 gives us 0. Is it included? Yes. We shade and then we go in that direction. And the conclusion, same. Alright, so this is easy, guys. So please make sure you know the graph method and the table. They will take you far. Alright, so let's get to 1.1.5. So this one is our third quadratic equation. So we always isolate the radical. Please don't jump steps. So this is going to be 4 minus x. Now in the next step, don't do this inverse operation already on the step that sorts it up first. So we do it in the next step. This is when we will do inverse operations to try and get rid of the square root. So this gives us x minus 2 equals, this is going to be 16, minus 4 times this is minus 4x by 2 is going to be minus 8x plus x squared. Please be quick about this, folks. There's no excuses you can make. Minus 8 minus 1 is going to give us minus 9x. 16 plus 2 is going to be giving us 18 equal to 0. Just rearranged. Could we factorize this? Indeed we can. So this is going to be x, this is negative, negative, this is 6 and 3. So therefore x is 3 or x is 6. Now we need to check here. The check is mandatory because one of the solutions might not be correct. Might not always the case. Now what we do, we run the check, folks, as I said, into the original equation. Please don't do it in the manipulated one, because if it is manipulated incorrectly, the answer may check out, but technically being incorrect. So if we put a 3 there, 3 minus 2 is 1, square root of 1 is 1. Put a 3 there, 3 plus 1 is 4, 4 is equal to 4. So this solution holds. Put a 6 in there, 6 minus 2 is 4, square root of 4 is 2. Then we've got 6 there, so already 6 plus 2 gives us 8. Now 8 is not equal to 4, so we need to strike that solution. Here the check is mandatory, as I said. Not doing it is suicide. Right, so let's mark it. So obviously the operation is important, factorization important, striking the solution is also important. So we've got 1, 2, 3, 4 marks, and of course getting our quadratic in standard form most likely would give us an extra mark. All right, so let's move on to 1.2. So 1.2 says a mother has a son and a daughter. The son is exactly 2 years older than the daughter. Okay, in a certain year, the sum of the ages of the two children will be equal to 75% of the product of their ages. Okay, cool. Now the question is, how old was each child that year? So meaning those two. Okay, cool. Now we're going to say let the age of the youngest be equal to x. Right, such that what's going to happen? We understand that the girl is going to be x plus, remember we're told here that the sum means in addition, plus sum of the ages. So we know that this one is 2 times the age of the other. Okay, so when the other one is 2, so basically the difference between them is 2 years. Or we can easily say, if we know this one, that one will be, the other one. If we like, we can say, yeah, there are many ways to do this, but let's just leave it at this. Right, so the sum of these two is going to be equal to 75%, so this is 75 over 100. Off, now off it means multiplication times the product of their ages. So the product is going to be 2 times x is going to be 2x squared. So this is the equation. So word problems, folks, are an important issue. They're starting to show up again. So get used to this. Right. So what do we do, folks? We can simplify this first. We know 2 goes once, goes 50 times. Right. And then what can we do here? 5 to 75 goes 15 times, right? And then to 50 goes 10 times. So 15 over 10 is 3 over 2. Okay, cool. So this implies that we've got, this is 3x is equal to, this 75 is going to be basically 3 over 2. Of course, you can use the calculator, x squared. Now we cross multiply the 2 and move everything around. So if we multiply by 2, what do we get? 6x is equal to 3x squared. Move everything to one side. We know that we've got 3x squared minus 6x equal to 0. We take out the highest common factor. We end up with 3x into x minus 2 equal to 0. Is that good? Yes, it looks good. So therefore x is equal to 0 or x is equal to 2. Obviously, there can't be a 0 here, so this is not possible. So this further simplifies that. The girl can say, therefore, the girl is 2 years and the boy is 2 times that. It's going to be 4 years. Nice and easy. So can you see 4 years is exactly 2 years older than the other one? Nice and easy. So obviously this is cool, folks, and we can check it out if we like. We can go back to the given expression and check if everything is going to make sense at all. As I said, folks, even though you may not know what this equation was meant to be, if the check is good, it means everything is good, even if there's many solutions. But the one that you got, if it checks out, you're good, okay? Unless the expression is written wrongly then. Okay, let's have a look. So the left-hand side, if x is 2, so it's going to be 2 plus 2 into 2. Right, so the left-hand side gives us 10. So if we look on the right-hand side, we've got 75 over 100 times 2 into x squared. So this is 2 squared. Hey, we're getting 6. That's not good. This is not good. This is not good. Wait. What did we... They told us that in a certain year, the sum of the ages of the two children will be equal to 75% of the product of their ages. What did I do wrong? 75% is 75 over 100 multiplied by, 2 times 1, so that's going to be 2x squared. And x here is 2. So my answer now is 6, guys. So what is cooking here? So it's 6, yes. And on the right again, 2 plus 4 is 6. Yeah, it's good. So 6 is equal to 6. So basically the left-hand side is equal to the right-hand side. So if this checks out like we see here, then it means even if there's other solutions, this is perfect because the equation is good unless the equation is wrong. So basically, the critical step for these kinds of problems is the equation itself. If it is not done properly, most likely everything is going to fail. So that's the critical step. So let's hope that is correct. So obviously we're going to get a mark for getting the equation first. Secondly, our gymnastics of factorization is perfect. Knowing that this is the answer and getting the other one. How many marks was this? 1, 2, 3, 4. Okay, 5. I don't see why, but it is what it is. Okay, but perhaps the other one could be for our quadratic in standard form. I suppose that makes more sense than this. That makes more sense than that. Okay, either way, 5 marks in the bag. So let's look at 1.3. 1.3 says, given xy is equal to 2x plus 10, where x and y are both natural numbers, meaning numbers without decimals, or we can even say positive integers. Right. Okay, but starting from 1. Now it says calculate the maximum value of xy when x and y satisfy the equation simultaneously. All right. So this is one of those simultaneous equations within a single equation. So we need to be quite strategic here. So we know that xy is equal to 2x plus 10. Now, what I often see immediately is that there's x and x, so we can bring these ones because they are relatives. So this implies that xy minus 2x is equal to 10. Right, we can factorize this. So this is going to be x into y minus 2 is equal to 10. Now the biggest challenge is to say, could we express 10 in this manner of the left-hand side? Now, we need to be quite strategic because whatever we do, this means it's an even number. Remember, any multiple of 2 is an even number. So we need to create a difference of some number and an even number. From there, we need something common, right? Because x is common to both whatever the number is and that even number. So if we look at 10 quickly, okay, but I need a difference. So for a difference, I can have 14 minus 4, right? So 14 minus 4 is 2 times 7 minus 2 times 2. And I can see 2 is common to both, like it was the case with x. So it looks like it's going to work, okay? So sometimes you just check things out a bit and then keep moving. So this implies that x into y minus 2 is equal to 10 is basically 14 minus 4. This implies that we've got x into y minus 2 is equal to 14 is 7 times 2, or 2 times 7. Let's do that. And say this is 2 times 7 minus, this is 2 times 2. Right, we factorize that, so x into y minus 2 equals 2 into 7 minus 2. Right, now we can already see that we have something similar here. Y can be any number, obviously, as long as it is an integer. We were told this is probably a good one because that's a natural number, 7. And we can see that x was the highest common factor because it was common, so x should essentially be this number. Again, that's a natural number. So we can say here, therefore, x is equal to 2, right? And y is equal to 7. Now we were supposed to find the maximum value of xy. We can say, therefore, xy is going to be 2 times 7, which is equal to 14. Nice and easy. Now the question is, we need to run a check because we're not sure if we're talking sense or we're just chancers. Remember, maths is not afraid of anybody. It just is a selfish bastard. It can show you off how ridiculous you are. So let's check. What are we going to check in the original? For these values we got, is our left hand side equal to the right hand side? Now let's say x is 2, y is 7. So x times y, meaning 2 times 7 is 14. If we look here, 2 times 2, that's 4, plus 10, that's 14. So indeed, it checks out. So folks, even if we got this one wrong, if it checks out properly, because the thing said these two satisfy the equation simultaneously, meaning at the same time. So obviously, we may be wrong, but I think we are correct because this checks out just right. So again, a bit of, trial and error can assist to get the business going. Okay, let's get to business, folks. Here, I suppose what is important, we're getting 4 marks, so perhaps for these two, and obviously for the answer, and this was the critical step, I believe. Okay, whichever you choose, we can say the factorizations including the technique. Easy 4 marks, and of course we smile on, folks, with these 27 marks of the first question. You can already see that this is a higher grade question. This one is a higher grade question, as well as this one. Perhaps that one is a bit mild though. I think this one would fit both standard and higher grade. But the last one is definitely a higher grade. There's no manga business about it. Okay, let's get to question 2. So question 2 says, simplify the following expressions fully without using a calculator. So we know that this is part and parcel of algebra / arithmetic. So 2.1.1, we've got the square root of the square root of 81 multiplied by x to the exponent 6. So be very careful how these expressions are written. You can see the cap only covers 81. So this is equal to the square root. Now square root of 81, folks, this is basically 9. There's no questions about it. Multiplied by x to the 6. Now using our rules here of surds, this is square root of 9 times the square root of x to the 6. Now square root of 9 is 3. This one is going to be x to the 6 over 2, right? When we convert to exponential form. So this gives us 3x cubed as our answer. Again, folks, here's the thing. Check the damn thing. Do not be complacent. How do we check? We just assign a value for x. Let's say x is equal to 2. But make sure it's not a big number. With exponential equations, if you put a big number, you might find yourself evaluating infinity, in which case this thing can tell you that, well, this is a math error. So be very careful. It doesn't mean it's not solvable, but it somewhat evaluates infinity, which doesn't make sense, although we know it exists. Right, so let's see. Now we're going to put in this value here and see what we get. Right, so let's do it on the calculator. Now, square root of the square root of 81 multiplied by x, which is now 2 to the 6. Please, guys, be very careful. Learn how to use the calculator. So the answer is 24. Now we come and plug this very same thing here and see what comes out. So if we look at this, it's going to be 8 times 3, right? So 8 times 3 is 24. So if your final answer is the same as what would happen up there, there's no way this is incorrect. Okay, right. Now let's get our answers. It's just 2 marks after all, so I don't know, 1 mark. And maybe here the conversion, it's crazy, guys. I don't know, this question is strange. Anyway, let's move. It's not a big deal. So 2.1.2 says, yeah, that one. So we've got 25 to the exponent k plus 1 times 10 to the k, all divided by 8 to the exponent k times 125 to the exponent k times 2 to the exponent 2k. Right, we know what to do here. We change all these bases to prime bases. 25 is going to be 5 squared, right? To the exponent k plus 1 times 10 is basically 2 times 5 to the exponent k, all divided by 8 is 2 cubed to the exponent k. 125 is 5 cubed to the exponent k times 2 to the minus 2k. Easy. So we go on, please be patient. So we FOIL or distribute that 2 to that expression on top. So this is 5 to the 2k plus 2 times, here the exponent distributes to the factors. So it's going to be 2 to the exponent k times 5 to the exponent k, all divided by, we do this, this is 2 to the 3k times 5 to the 3k times 2 to the minus 2k. Now we move everything to the numerator. First and foremost, these are like terms, so when you multiply powers with the same basis, we add exponents. So this is going to be 5 to the 2k plus 2 plus k, right, for that one. Then we take this one in the denominator, we subtract it, times 2 to the k. Then when we move this, we subtract this, it becomes plus 2k, right? Ne? That is the one, and then we subtract the 3k. Okay. So let's see, this is 5, 2. Now we've got 3k. So this one and that one gives us 3k minus 3k out. So we get 5 squared times, again, these ones add up to 3k and subtract the 3k. So this is 2 to the 0. So this is basically 25. Nice and easy. Again, folks, you run a check here because there's no need to walk away without these things. Here again, we do the same. We assign a value for k, but it has to be a small value. Let's just choose 1. Do not put big values for the exponents. You will run into big problems. Right, so whatever we do, folks, we put it in there and then see what comes out. And if what comes out is the same as this value, then we know we are good. Right, no matter what value you put, it should agree. I don't know what this thing is doing. It's irritating me. Please don't irritate me. Some belief though. Now let's do this fraction. We've got 25 to the exponent k. Let's say k is 1. It's going to be 25 squared. Ne? And then into 10 to the exponent 1. Okay, it's just 10. Divided by 8 to the exponent k. Again, it's just 8 into 125. Exactly 125 alone, into 2 to the exponent minus 2. Right. I'm getting 25, so it means our simplification is excellent. So please, guys, do not take these things for granted. Remember, in maths, you don't know what the answer is. You've not seen the memo, but you can be assured when you check solutions to most of the problems, not all. If you check these, you will see that at most you will be able to do it. But there are some questions where essentially the procedure is key. Usually those are the types of questions where there is a specific formula, we just substitute and go to the solutions, but we are unable to check them. Usually sequences and series, it's a bit difficult to check there. But again, it depends on the type of question. But most questions in algebra can be checked, and most questions in functions can be checked. So please, folks, don't lose these marks. Now let's see, where are they? How many marks? 4. Okay, so for me, I think this step is cool. Numerator, nice. Denominator, nice. And then this whole shenanigan there, and then the final answer. Of course, there's multiple areas to do this, but sometimes with exponential expressions, the mark allocation can be endless. And you will see in the past papers, like back in the days, you would see that this would be worth 8 marks sometimes. But of course, they would make sure it's a little bit naughty along the way. All right, so let's have a look. We've got 2.1.3. This one is these nice types of questions. The square root of 3 to the exponent 2006 plus 3 to the exponent 2024 all divided by 2 to the minus 2 times 3 to the exponent 2022. Great. So of course, folks, inspection is important. We can already see that of these big exponents, this is the smallest. So we need to try and create this exponent in those two on the numerator. So this gives us a chance to do some stuff. So what do we know? We know that this is 3 to the exponent 2022. Now to get to 6, we add 4, right? Plus 4. And then times, not times, but plus 3 to the exponent 2022. To get to 4, we add 2. All divided by 2 to the minus 2 times 3 to the 2022. Now we've got a situation where we need to break it up using our exponential rules. So when we add, we simply multiply. So this is 3 to the 2022 times 3 to the 4 plus 3 to the 2022 times 3 squared, all divided by 2 to the minus 2 times 3 to the 2022. Now we can see there's a highest common factor. The only annoying part of this is just the writing. It's painful, I promise you, and it's easy to make mistakes because of just the magnitude. So this is common, so we end up with 3 to the 4 plus 3 squared, all divided by 2 to the minus 2 times 3 to the 2022. Now this will take this out. Maybe let's do it this way. These ones divide to 1. So all we have left is this situation here. Now we can just put everything under the same spot. So that sum there, this is 84 plus 9. 81 plus 9. That gives us 90. Times, this is 2 to the when we move it to the numerator, it's going to be 2 to the 2, which becomes 4. Right. Now, we can see that 4 is a perfect square, so this is 2 root 90. Now, 90 is also made up of 10 times 9, so we can further simplify. This is 2 into the root of 9 times 10. So if we take this out, this is going to be 3 times 2 root 10. So this is going to be 6 root 10. Nice and easy. All right, again, this one, unfortunately, as I said, if you put this on the calculator, you get a math error because this is infinity already. So it's all about procedure. So there's no way you can check, but if you follow the procedure properly and be meticulous, this is one of those questions you are not able to check, but certainly are in a position to follow each step and hope everything is good. So you just check that all the laws were applied correctly and everything is good. So usually with factorization, we get a mark. Hopefully this is good. We get our mark. 10 is not made up of perfect squares, so to speak, so we can't break it further. And then, what can we do now? How many marks was this? Just 3. Wow, crazy stuff. Anyway, probably using exponential rules there. So as you can see, a lot of work, but no reward. All right, so that's it, folks, for simplification. Let's get to 2.2. And if you're interested in this memo, I will attach it in the description down below together with this question paper. If you're grade 12, you want to look at these, trust me, they will haunt you in your next exam. Okay, we're solving for x without using the calculator, so every step needs to be shown. 2.2.1, we've got 3 x to the minus 5 over 3 minus 96 is equal to 0. Right, let's just move the number to the other side. This implies that 3x to the minus 5 over 3 is equal to 96. Now the question is 96 a multiple of 3? Yeah, we think so. So this implies, again, exponential expressions, guys, take a lot of space. They are not fair in this regard. We know 96 is 32 times 3. Right? I hope so. Let's check it just in case I'm making a meal. 96, so let's check. 3 to 9, 3 times 3, 9. We know that we're doing the deed, so this is nothing. Drop the 6. 3 to 6, 2 times that's 6. And yes, so this is good. Of course, you don't have to show this. Okay, you can even cheat with the calculator, but be very careful. Okay, so folks, we can divide by 3 on both sides. What do we get? We get x to the minus 5 over 3 is equal to 32. Right, so if we want to get rid of this inverse operation, so we're going to have x to the minus 5 over 3. We then raise it to the exponent, which is a reciprocal of this, so this is minus 3 over 5. Cool. What we do on the left hand side, we must do on the right hand side. So this is going to be 32 to the minus 3 over 5, what we did. Now the nice thing is that the 3 takes the 3, the 5 takes the 5, the negative takes the negative. So we get ourselves x alone is equal to, we can do something about this. This is 2 to the exponent 5 into minus 3 over 5. Now when we distribute this, we get it nice and easy. So this implies that our x is going to be 2 to the minus 3. And we can say therefore x, when you convert to positive exponents, powers, it's going to be 1 over 8. Nice and easy. Again, folks, with equations, you have no excuse not to check, because if you don't, you are dead, right? But check on the original, provided it is copied correctly. So let's quickly do it. So we're going to have 3 into x is 1/8 all to the exponent minus 5 over 3. This we subtract 96. It gives us 0, so this is good. So if it checks out, you know that there is no chicanery committed. Okay, how many marks? 3. Hey. Perhaps the method here, the answer, and whatever we did here, probably good enough. Okay. Right. Let's get to the next one. So 2.2.2. We have to solve 27 to the exponent x is equal to 243 times the xth root of 9. Okay, cool. So this is not a problem. So we've got 27. We can choose to express this in terms of 3, or we can choose, I think let's do the prime base business. So this is 3 cubed to the x is equal to 243. let's see, I think it's 3 times 81. Let's check. We can just say 3 to 2, 4, 3. This is going to be 3 to 24 is 6 times. 6 times, okay, 8. 8 times 3, that's 24. We subtract, this dies, and then 3 here. Yes, 1 times 3, yep. So it's 81. So 243 is 81 times 3. Now this is basically 3 to the exponent 5. Because 81 is 3 to the 4 times 3 to the 1. So that makes it 3 to the 5. Okay, that is cool. And then we're going to have 9 to the 1 over x using our laws of exponents. Now we've got here 3 to the 3x is equal to 3 to the 5 times, this is 3 squared to the 1 over x. So we've got 3 to the 3x is equal to 3 to the 5 times, we sort this out, it's going to be 3 to the 2 over x. Right, so again, laws of exponents are still in the house. Now, multiplying powers with the same base, we add the exponents. So this is going to be 3. 5 plus this, it's going to give us 5x plus 2 all over x. These guys were brutal here. Anyway, so all I know is that, folks, if I say 5 plus 2 over x, you know, this is all 5 over 1. So 1 times x is x. Cross multiply these. That's what we end up with. 5x plus 2. Exactly that. So please know how to deal with fractions. Again, you don't have to show any of this. Now, folks, we've got powers with the same base that are equal, so we can equate the exponents. So 3x is equal to 5x plus 2 all over x. Right, we multiply by x, the common denominator, so we get 3x squared is equal to 5x plus 2. We write this in standard form, 3x squared minus 5x minus 2 equal to 0. Could I indulge on this page? I'm just hanging on. Right, let's try to factorize. Most likely it should work. So we've got 3x, we've got x2. So this has to be 2 here and 1. Now we need this to be negative. So this must be negative, this must be positive. So sort it. So we know that x is equal to minus a third, or x is equal to 2. Are they both correct? Since we didn't do any inverse operations here, in a case of squaring and stuff, they should both be correct. But we can check. How do we run a check here? Remember, as I said, with equations, guys, there is no excuse for not checking that the left-hand side is equal to the right-hand side. Now let's go. Let's just put it on the calculator. 27 to the exponent, let's say minus a third for that first one. Let's see, what answer do we get? We get a third. Okay. Then let's see on the right-hand side, what do we get? 243 into the minus don't root. Okay, let's just do it quickly first, and then we go back and remove our exponent, and then we put that 1, that minus a third. Whew. Yeah, what an expression there. But the calculator can handle it. So and it trail, I'm getting a third, so this is good. So the left hand side is equal to the right hand side for that. So obviously this should also work. Square root of 9 is 3. Then we have 3 times 243 is 729, and 27 squared is the same. So again, this second solution holds. So this is cool, folks. So we are winning, and normally when we factorize we get rewarded. So the 3 marks are heavy at the bottom, and in fact applying some exponential rules here, maybe. Yeah, doch. What can I do? What can I do? What can I do? Probably for our troubles here. So 1, 2, 3, 4, 5. Again, folks, as I said, the mark allocation with exponential expressions is quite crazy. There's too many areas to consider. So as a result, just do your job. If you fail, you'll be given marks along the way. Now 2.3 says, if it is given that the fourth root of 2 is equal to a and the cube root of 3 is b, determine this one in terms of a and b. Now this is a higher grade question. Again, let's handle it. So we know that square root of 32 minus the square root of 18 plus the cube root of 6 times the cube root of 4. All right, so this is an arithmetic expression. Let's deal with it. So we know, folks, we change these to a perfect square and a prime number. So 32 is 2 times 16. So this is basically okay, let's just show the steps a bit for those who may not know. 32 is 16 times 2 minus, always choose a perfect square and a prime number. 18 is 9 times 2 as well. Plus, now with this one, there's a rule. If we're multiplying 2 cube roots, we can put them under the same cube root, but multiply what's inside. 6 times 4. Right. So let's keep going. So obviously the square root of 16 is 4. So this is going to be 4 root 2 minus 3 root 2 plus this is going to be the cube root of 24. Cool. Let's keep moving. So 4 root 2 minus 3 root 2 is just root 2. Plus, let's check it here. What is this? This is 8 times 3. So this is the cube root of 8 times 3. This goes on to say square root of 2 plus the cube root is split again of 8 times the cube root of 3. So back and forth, unfortunately. So square root of 2. Guys, my eye is, I'm having a blepharospasm. Alright, this is the cube root of 8 is 2 cubed times the cube root of 3. Hey, this one is dangerous where I put it. Right, okay, folks, so we can already see that the cube root of 2 cubed is just going to be 2. So this is the square root of 2 plus, this is just going to be 2. Hey, what are you doing? 2 times the cube root of 3. Alright, so this is cool. So we can already see that the cube root of 3 is b. So this is fine. But what about this? Yikes. So now, folks, a bit of a check on the side. We know that if we look at this fourth root of 2, this, now for us to end up here, remember the fourth root of a number is basically the square root of a square root, isn't it? So let's say here we had the square root of the square root of 2. But now how did we end up with just this one? It means this thing must have been squared. So this whole shenanigan is the same as just the 4th root of 2 squared like this. Okay, so technically this is what is the case, I believe. Now what I'm going to do, I'm going to write it in this manner. So this is the same as the 4th root of 2 all squared. Right, and then plus 2 times the square root, not square root, but the cube root of 3. At this point, we finish it off. We know that the 4th root of 2 is a, so this means we've got a squared plus 2b. Again, here it's a matter of procedure, guys. There's no excuses. If the process is not done, and I can tell you this must have been a problem for many students to take it here. So please, guys, take your time, learn the algebra. There is an algebra course in this channel that you guys can take advantage of, but that's if you want. If you don't, is your problem. I don't care. You see, most is like this. So this is cool. This is cool. 2 marks already in the bag. So what else was there? Yikes, guys. Yo. This step, maybe 3. Perhaps this one 4. Yeah, is not doing the things. Is not doing the things, Buffett. So I think either this one or this one will take the mark. Again, 5 marks in the bag, folks, as long as everything gels. So we smile with our 22 marks and we continue smiling on. Now functions, folks, is the things you like. So let's get to functions quickly. Now, given the function, yes, it's the hyperbola, the standard hyperbola. Right, okay, write down the equations of the asymptotes. I'm not wasting time here. F of x is 4 over x minus 4 minus 2. 3.1. Write down the equations of the asymptotes. Of course, we know that x is going to be equal to 4. We take the opposite sign. We can just say we take that denominator, equate to 0, and solve for x. The second one, y is equal to minus 2. We take this guy as it is for y. Nice and easy. So there is our 2 marks. So 3.2 says, calculate the y-intercept of f. So we know that for y-intercept, it is such that we've got f of 0, which is 4 over 0 minus 4 minus 2. Therefore, f of 0 is equal to, this is minus 1 minus 2 is minus 3. Therefore, the y-intercept is going to be 0 and minus 3. Okay. Nice and easy. So we are done. That was what we were supposed to do, and we did it. Remember, a y-intercept, guys, is the point. So we need to do it in the ordered pair. You will be punished for not doing it. It's not the y value, it's a point with both x and y. If you just do this here, you will lose the last mark, okay? And don't say I didn't warn you. So 3.3 says, we need the x-intercept. I mean, these are grade 10 questions. Come on, guys, don't ask this nonsense. Grade 11s must be given some respect, you know. Can't be asking, find the intercepts. That's grade 9, grade 8, grade 9, grade 10 stuff, man. Stop. Just tell them to draw the depth graph. They will know what to do. They will figure it out. They must figure it out, okay? Okay, all right. Now for the x-intercept, what knowest thou? 0 is equal to 4 over x minus 4 minus 2. Transpose the 2, it becomes 2 over 1 is equal to 4 divided by x minus 4. Cross multiply here. Please, you don't show this. Don't do this in the exam. Don't write these arrows. This is me demonstrating. 2 times x is 2x minus 2 times 4 is 8. 1 times 4 is 4. Move it out. So in fact, I don't have time. X is equal to transpose 8. We get 12. 12 divided by 2 is 6. So therefore, the x-intercept is going to be 6 and 0. Right, again, here it's a matter of procedure, guys. You can't prove this. It is so. These are the questions where procedure matters and making sure everything is followed properly. We knew that this is coming, so let's do the sketch in the next page. So 3.4, we've got our Cartesian plane. Right. Here we just need to know what is where. There's no need to draw this to scale, origin. Right, so we start with the asymptotes. If this is negative 4, this is going to be positive 4, but I'm going to make sure it's here. It's not too far away. Nonsense. Okay, not bad. So this is 4. And of course, with every asymptote, the notation is a broken line. Okay, cool. So this is where this is. And then the horizontal one is at minus 2. We can pretend this is here. Again, we know that this is minus 2. And asymptotes must be broken. These are the broken hearts of mathematics. And I told you what an asymptote is in a video on revision on functions for grade 12s. Even grade 11s can look it up and do the things. All right, so what are we doing here, guys? We are cutting. By the way, when a is greater than 0, that constant a is greater than 0, the graph is in the first and third quadrants. Right, so it's like this. So obviously it will be cutting here. So the graph is cutting at 6. We saw that. This is 6, which makes sense. And of course, these graphs approach the asymptotes, but never, ever play hide and seek with them. So masipale ngapha le izosmosha. So minus 2. Le yona sizoyibhala la. Hayi impi. So there we are. So we know that this cut at minus 3. So can you see our calculations are not bad. They are good for business. And then of course we write F somewhere. Nice and easy. That's all we need to show, folks. Now, how do we score the marks on this one? We get the marks for the shape. And we get the marks for the intercepts. But remember, both of them have to be correct for us to get that 1 mark. And then the last mark is for the asymptotes. Again, both of them have to be correct for us to get our mark. Okay, remember this. It is what it is. You can cry if you want. Nobody is listening. So better not cry at all, because there's no point of wasting your water in the eyes. You need them for tears, you know. Tears are good for trapping the damn bacteria and particulate material to stop excoriating your eye. Stop crying for nothing. Write down the values of x for which our f of x is greater than 0. When is our f of x greater than 0? You know that our f of x is greater than 0 here. Okay, maybe let's do it like so. So folks, that is the region there. Okay, you can see that this is the only place where f of x is greater than, and it is equal to 0 at 6. So we can write here x must be less than and equal to 6, but certainly greater than 4 because that's an asymptote. Usually for this we get 2 marks. Nice and easy. So 3.6 says, determine the equation of the axis of symmetry having a positive gradient. We know that the axis of symmetry is such that y is equal to positive gradient is going to be x minus p plus q. So this means y is going to be x minus p is what we see here. We write it as it is, x minus 4 plus q is what we see over there, and we write it as it is, and then we solve. Therefore y is equal to x. Of course we just distribute 1, so this is minus 6. Nice and easy. Alternatively, another student may want to use the center of this graph. Write y is equal to minus x plus c. The center is the point of intersection of the asymptotes right there. So we know that through that point, which is going to be 4 is to minus 2, what do we get? We get minus 2 is equal to, why did I write minus x? Is equal to 4 plus c. We can already see that our c, when we transpose, we get minus 6. Therefore y is x minus 6. Either one is good enough. So this business here is cool, and that business is cool. Okay, even an answer only, you get 2 marks. Normally here we say substitution and answer. Nice and easy. Okay, so 3.7 says, determine the point of intersection of f with the axis of symmetry having a positive gradient if x is between 0 and 4. Okay, so that's cool. So what is this trying to tell us? It's trying to tell us that we want a point on this graph, because a point on that graph is x that is already greater than that. So we want a point where this axis of symmetry will be intersecting this half of the graph. Okay, cool. So how do we do it, folks? We know that this point, right, is such that we have 4 over x minus 4 minus 2 is equal to x minus 6. So we can see that everything is over 1, right? So we can just multiply by our common denominator, which is x minus 4. Right, if we do that, we just get a 4 minus 2 into x minus 4 is equal to x minus 6 into x minus 4. Nice and easy. So this implies that we've got 4 minus 2x plus 8 equals, FOIL this out, x squared minus 4 minus 6 is minus 10x plus 24. Now we write our quadratic in standard form, x squared minus, if we bring in the 2, we're going to get minus 8x, and then 24 minus 8 is, wait. This is going to be 12. First, 24 minus 12 is going to be plus 12, equal to 0. Nice. Now, what we need to do is to factorize. So x, this one is going to be minus 6 minus 2. Now we can already see that the one that we want, x is equal to 2. We ignore this one because this one would be exactly over there. So this means this line is doing that stuff. The line is doing stuff like this. So we want this point over there. All right, so cool. Now we can substitute. We can say then we know that y is going to be equal to x, which is 2 minus 6, which is going to be equal to minus 4. Didn't we see it? We saw that this point, when we do this business, it's going to be exactly somewhere there. So that's essentially less than minus 3. So this makes, therefore we can say the point here is 2 minus 4. Nice and easy. Okay guys, interesting stuff, but easy material to handle. Okay, so what do we do, folks? The method here. Thank you very much. Simultaneous equation, and then factorize is good. The 2 points. So this is 4 marks. You know most. I think for our troubles, boiling to this is good, but we can actually look at any of these 2 steps for the extra mark. Nice and easy, folks. So we take our 19 marks and move on. We don't want to spend time talking gibberish. Thank you, and thank you. It's a point in the 4th quadrant, and the graph is telling the tale. So question 4. We're told here that the equation of a straight line is given by this, and the properties of a exponential equation are that h of 0 is 3. What does that mean? Y-intercept. Right, the value of b is greater than 1. So what do we know? It's an increasing function. Well, because we see that the coefficient is an invisible one, so it means this graph is increasing. Okay, so this means this is a graph that increases above the horizontal asymptote q. Now we're told here that y is an element of real numbers, but y must be greater than 2. So it means 2 is the cutoff. So that's our asymptote. So q must be equal to 2. So we know what to think here. So it says write down the values of the value of q. So we already know, folks. So that 4.1. Q is what is the restriction there. So q must be 2. If everything must be greater than 2. Happy? You don't have a choice but to be happy, right? So 4.2 says draw the neat sketch of G and H on the same set of axes. Clearly show all the intercepts with the axis and the asymptotes. Okay, cool. We don't have time, guys. Here we don't need to do any stupid calculation. If someone taught you this thing, yes, use it, but do whatever you can. For me, I know that the y-intercept of this graph is a 3, whereas the y-intercept of the other one is also a 3. So a 3 is the common y-intercept. So let's say 3 is here. And I want our horizontal asymptote is at 2. So let's say 2 is over here. So we will have our horizontal asymptote doing horizontal things. Horizontaling like this. So it is horizontaling, if there's such a word, but I'm giving it now, okay? So the exponential is increasing, guys, cutting at that 1. So it's cutting and cutting. So this is our h. Okay, let's wait before we do anything. So this is at 3. Right, so this is a common point of intersection because that was the y-intercept as well there. But now this is a positive gradient. So positive gradient means this one will cut there, but the x-intercept is going to be minus 3/4. So minus 3/4 is doing these things here. So I don't know if it goes like this, but minus 3/4. Conjugate 3/4 is what? 2/4 give us a half. So it's a half and a half. Dang. Is it a half and a half? No, it's a half and a quarter. So if we say this is 1, so it's doing things like so, man. At this point we don't care that much, so there it is. Just do the sketch, guys, and be happy. Okay, so this is what I expect. So this would be G, this is H, and we've got this here, and then this one is minus 3/4 over there. Graph is complete. We have no issues. So we're getting 5 marks. So let's see, how do we score them? First, shape and the intercepts. They must both be correct for the graph of H. And then again, the shape for the exponential and its 1 x-intercept. So that should also be correct. Sorry, the y-intercept and the asymptote. So how many marks is this? 5 marks in the bag. We are moving. 4.3 says, if it is given that 2:11 lies on H, calculate the value of B. Okay, nice and easy. So we know that H of X is basically B to the exponent X plus 2. Okay, so now through this point, 2:11, we know that 11 is going to be B to the exponent 2 plus 2. So we transpose the 2. 11 minus 2 is 9. It's going to be B to the 2. This is 3 squared is equal to B squared. Therefore, B is 3. Right. We were looking for the value of B, right? Right. Nice and easy. So substitution, guys, and answer. Excellent stuff. Why are we getting more than 1? Okay, perhaps for that little sketchy stuff. Right, so 4.4 we are interpreting. It is also given that K of X is H of X minus 1 minus 11. So this means we are moving the graph of H 1 unit to the right and 1 unit down. So this is 2 transformation, horizontal to the right and vertical down. Okay, so let's see. 4.4.1 it says write down the x-intercept of K. Now obviously, folks, we need to be skilled now at checking things out. Remember, we didn't have an x-intercept in K. So if we move this to the right by 1 unit, will it affect anything? Moving the graph horizontally does not give us an x-intercept, okay? But what gives us an x-intercept is moving the graph down. So if we move this graph down, where will our x-intercept be? Okay, so we need to find a point on this graph of H that is giving us 11, because we are killing the 11. Can you see? If we're killing the 11, this is the point. So 2 is to 11. So this means the 11 part, if we drop it, it's going to lie right on 2. So this means the x-intercept here is going to be 2. So we know that this is 2 and 0. Okay, so we're just dropping this point, because if we cancel the 11 here by saying minus 11, this gives us the point. But here's the problem. This point moved to the right by 1 unit. Now this changes a bit, because as much as we said it's not going to affect it, it actually will, because now the point that will give us 11 is going to be the one before this. so it's going to be 1. Okay, wait. If this shifts to the right by 1 unit, it's going to be 3, because then 3 gives us 11. So essentially this is going to be 3, because this is going to be 2 plus 1, which gives us 3. Okay, interesting stuff. Right. For those who don't know what I did, I took this point, 2 is to 11, because obviously if I'm killing the 11, it should be this point that becomes an x-intercept. Now here I'm killing the 11, but I'm also moving it to the right by 1 unit. So if you're moving to the right, you add, and that's how we end up with this. Obviously it's just 1 mark, because this should be done by inspection. Alright, so 4.4.2 says, write down the equation of k in terms of this one. Okay, meaning we're going to have to write the equation and have a horizontal asymptote and stuff. And of course the exponents. Alright, okay, alright, we have no issues. We know, folks, that k, of course, once it says write down answer only, let's just do the rough work here. We know that k of x is going to be h of x minus 1 minus 11. So h of x, we saw that this is going to be 3. Where we see the exponent x, we replace it with x minus 1. And then where we see the 2, we then subtract 11. Nice and easy. So this becomes 3 to the x minus 1. And here it's going to be minus 9. Yep, that's the one. So we will write here that k of x is going to be 3 to the x minus 1 minus 9. Nice and easy. Okay, guys, 2 marks for the answer, perhaps for the 2 things, the exponent and the asymptote, or just say 2 marks for the answer. So guys, we walk away with these easy 12 marks, and you can see there was hardly any struggle here. Okay, maybe this question is typical of higher grade stuff, because obviously those transformations can be quite an issue, including this one. Standard graders would not know what to do there. All right, let's get to the next one, guys. Question 5. So question 5 says the graphs of m of x is equal to, this one's a straight line equation, good. Y-intercept is at 3. Yikes, where is the x-intercept? Does it matter? Maybe not, but let's see. If this is 0, cross multiply to it's 6. Transpose the 3, the 6 there, it's minus 6 divided by this. Minus 6 divided by minus 3 is going to be 2. So this would be the 1 there. Okay, more like it. Again, change in x over change in y. We change the sign. So this is 3 over 2 minus. Good. It's done. And n of x is the parabola. So the parabola has a y-intercept at 11. It's already shown. And we can determine the coordinates of the turning point by completing the square here. Nice and easy. So let's just try to do this. So we factor out the 2 first. So it's going to be 2 into. Then we take the x. We take the sign between these. So 8 divided by 2 is 4. We have that. It's going to be minus 2. We square this. And then 11 here is going to be 11 over 2. Minus immediately the 2 squared. Okay, let's quickly deal with this issue. I hope I'm right. So obviously I can see that b is somewhat directly above this, so I know this is good. So my equation here is going to be 2 into x minus 2 squared plus, let's see, 11 over 2 minus 4 is 3 over 2. When we bring in the 2 there, it becomes just 3. So this is how this ends up looking like. All right, so we can already see that this is going to be 2 is to 3. Again, if you look at this turning point, it looks almost in there. Of course, be careful of approximating things that were not given as such. But of course, folks, keep an open mind. Sometimes try to understand the question very well before you proceed. You don't always have to rush. Okay, A is the y-intercept of M, we see it, and B is the turning point. Yeah, already found our coordinates of the turning point, because it's always the opposite sign of that and exactly as that is. Okay, once we write it in the vertex form. Let's keep moving. So 5.1, we've got 5.1.1. I write down the coordinates of A. Can you see it's easy? Y-intercept is 0 and 3. Nice and easy. You see? 5.1.2. Determine the range of n. Now n is the parabola. So this is 3 marks. So how would we know the range? It means we need the y-intercept of the turning. I mean the value of y at the turning point. And of course everything above it is good. So if it says determine, we can just write here that basically n of x is equal to, no one will ask how did you do it, as long as you know you did it well somewhere in the rough work. If this is the case, we can just write therefore the range is equal to a set of y values such that y is greater than and equal to 3, where y is an element of real numbers. I like this set builder notation, but some people can just simply zoom into this inequality. That's also perfect. Or one can even write the interval notation, which we can write y is an element of 3 is included and going to positive infinity, which is not included. So this is cool, however you choose to write this. All right, so good. So for 3 marks, guys, be very careful. You can't just write one thing only. That's what I'm trying to emphasize. This is mark worthy. This would be 2 marks. Okay, whatever. But one can still use, for the y value here, one can use y is equal to 4ac minus b squared over 4a, right? And you will see that y is going to come up as 3. And then do your thing. So either way, there are many ways to kill the cat as long as the cat is dead. We are happy. Okay, I'm not happy when the cat is dead, by the way, but of course we will assume we are. Now, if it is given that t of x is 3 to the 1 minus n of x, determine the largest value of t. Holy Spirit, don't waste my time. So do you see what happened here? This is 1 minus n. Okay, so 1 minus n. So can you see minus n of x, which means we're multiplying our parabola with a negative. So we're doing a vertical reflection of this graph. So this means whatever was here is going to go up there somewhere, right? And then the parabola will do the parabola things like that. Okay, so it still does the parabola things, but now the vertex is sitting there. All right, so let's have a look. And obviously once we do that and then we add 1, so we're even moving it further, that if we reflect it first and then we're moving it up so it goes even higher. Maybe let's say it was here. Now we're moving it 1 unit higher. Hey, but now we have a problem. You see, we have a problem. We have a problem. Our problem is the problem. Okay. So folks, this one is killing us just for 2 marks, and it means answer only bafethu. So let's check, how do we deal with this business? We're going to have 3 to the 1 minus n is this expression. So this is going to be 2x squared minus 8x plus 11. Right, we've got 3 to the 1 minus 2x squared plus 8x minus 11. Sort it out. This is 3 to the minus 2x squared. The 1 and the 11 will kill each other. So we're going to have plus 8x minus 10. Now we need to find the maximum value of this thing. As I said, the maximum value is the y value at the turning point. So y is equal to 4ac minus b squared over 2a. Sometimes when the question is a bit naughty, you just do naughty things. So this is 4 into a is minus 2. C is minus 10. Minus into 8 squared. All divided by 2 into minus 2. So let's see what that y value is. It better be big, or else I'm going to be angry. Right, so this is 4 into minus 2 into minus 10 minus into 8 squared, all divided by 4 into minus 2. And yima. Don't Google. You cannot give me this. No. It's not possible. Yahana. I don't agree. I do not agree. First of all, this transformation is lying to me, because if we reflect this vertically, the y values, okay, maybe they change, right? Yeah, what was positive becomes negative. I get it. Okay, all right. But I can't have a maximum that is negative. It's impossible. It's impossible. Are you kidding me? All right, let's just double check again. 2x squared minus 8x plus 11. We distribute a negative. So this is minus 2x squared plus 8x minus 11. 1 minus 11 is minus 10 plus 8x minus 2x. So this and this must be positive. Minus 8 squared. By the way, this is going to be 4 by 2. That's 8. 8 times 10 is 80. 80 minus 64. Yeah. It's correct. So it means our maximum is down here. Hey, man. Oh yeah. I am stupid. Sorry guys, I misled you. You see, I forgot about the axis of reflection. The axis of reflection is the x-axis. So if this point is 2 meters there, it's going to be again, if it is 3 units from there, it's going to be 3 units again from here. So from 0, it's going to go to minus 3 and 2. Now we're going to move it 1 unit up. So if we plus 1, there it goes to 2. Okay, I'm happy. So this is minus 2. Can you see? Sometimes certain things take a moment to figure out. Okay, there's no ready-made answers, buffet. Just do your thing and always try to make sure you are doing the right reflections. Now, cool. Now I understand. I'm happy. I'm good. Now, of course, guys, for 2 marks here, I'm just going to write here that t of x is equal to 3 to the minus 2. So what is it? The largest value of t, we can say therefore t max is going to be, this is the 1, so this is 3 to the 1, sorry, 3 to the minus 2 is 1/9. Great. So of course, guys, you get a mark for this, you get a mark for your answer, or 2 marks for the answer. Here, when we're told to determine, we can do side calculations. We don't have to show everything. Wow, what a killer. Higher grade question, obviously. Higher grade. Hey, this grade 11 paper was hot. Quite a great. Now, if it is given that 2x squared, 2k, determine the values of k where the roots of n have the same signs. Okay, so what transformation is this? Well, we're gonna do it. Let's look at it. So this is 2x squared minus 8x is equal to not 2x but 2k minus 11. So we sort it out. This implies that 2x squared minus 8x, bring in these things, it's gonna be plus 11 minus 2k equal to 0. Now what have we done? What we have done is this thing. That is this. So the roots will have the same sign. Hey, this question, it's supposed to be easy, man. But now it's not trying to be easy, you know. I'm looking at 2 possibilities, you know. This 2x squared minus 8x plus 11 is equal to 2k. You know, seeing that this is a constant, this is good. We can just use a straight line because this, let's just drop this for a second. I'll show you something about it later. Now we can see that the parabola is equal to, the parabola as it was given is equal to a horizontal line because k is a constant. So this is a horizontal line. Even if we multiply it by anything, still will be a constant. So this means our line is something like this. It's a horizontal line. Ne? So what we do, we can just copy, paste. You know, we can have it here, perhaps touching this once. Copy and paste. We can have it cutting here somewhere. Copy and paste. This one is the easiest to do. So always when you can't get this one, you see this is one of the critical points. When we lose one of the intercepts that are positive, copy and paste. So use your ruler there so we can put it over there. And of course, this is it. So this is the line y is equal to 2k. It's a horizontal line. And we can see that k is less than 0 here. Even this one is included, but I mean, it doesn't help. So here, this is the line y is equal to 2k here is nothing but 3. Right, again, 2k can be represented by 3. It can be anything, remember? So this could be the value of that. And here, this is when the value is between 3 and 11. Okay, nice. And then here, this is when y is equal to 11. Again, this could still be our friend over there, as it would be the case over here as well, and everywhere else. Cool. Now we can already see that if we want the roots with the same sign, it's here. So this root here is positive, and that root here is positive. Remember, roots are the x-coordinates of the points of intersection of the two graphs. But here, this is positive, this is 0. 0 is neither positive or negative. This one is positive and this one is negative. So what is the correct dons here? This is the one. So this is what gives us the answer. So for this, we can just write our conclusion and say, therefore, x not x but k. Remember, we're looking for the values of k, but now what is k in this case? This is 2k. Perhaps we can write here, this implies that 2k must be less than 11, because it can't be 11, and it can't be beyond 11 because we lose this. And this must be greater than 3, because at 3 there's only one root there. Okay, cool. But now we're looking for k, not 2k. So therefore, divide by a positive number. This is 3 over 2. K, this is 11 over 2. Nice and easy. So be very careful not to forget this. All right, guys. So I think we've done justice here. Again, it's a matter of technique. Otherwise, not a big deal. Now, the other one was going to kind of cause us problems, guys, because you see the vertical shift, let's just ignore it. The one that I was trying to do, the vertical shift is a bit uncomfortable, but I can show you the best way to use that would be to use nature of roots on the side, because you can still write an answer only here. Although it might hurt. Perhaps you might want to write first this, because to get the marks, I would suppose this would be, okay, 2 marks, this one, and then perhaps that would be a mark just to write the expression. But let's say you chose to write it this way. You would write 2x squared minus 8x, transpose the 11 and transpose the 2k equal to 0. This is to suggest that we are shifting this graph vertically down or up by this, so that we've got 2 roots. Now, what you would do here, you would probably do the discriminant on the side and say b squared minus 4ac must be less than, greater than 0. Obviously, because these roots must be unequal, the first thing. So we start, and then we're going to say here, this is 2. Okay, but this is going to be a bit horrible. I'm thinking space is already gone. So let's just say you're continuing down here. And then sizovela ngapha. So you could write 2x squared minus 8x plus even 11 minus 2k is equal to 0. And then we know that b squared minus 4ac must be greater than 0, because first they must be unequal, obviously. Now let's have a look. So b here is minus 8 squared minus 4 into 2 into c, which is 11 minus 2k greater than 0. So this is 64 minus, this is 8, minus 8 times 11 is 88. So this is 88 plus 8 times 2, that's 16k greater than 0. Now let's see, we're gonna have 16k greater than, let's say 64 minus 88, it's minus 24. We transpose this thing, it goes over here to be 24. So we can say k must be greater than 24 divided by 16 is 3 over 2. So we saw that k must be greater than 3 over 2, but now the problem with this, it's incomplete. You would be forced to use the quadratic formula. Okay, so we can say, but the roots are in this manner. Of this equation, x is going to be equal to minus into minus 8 plus or minus the square root. Now, what did the discriminant give us? It gave us this guy. So you can just quickly zoom into that. So this is just going to be 16k minus 24, all divided by 4. Right. So this is what the roots would look like. Now the question is, for them to be the same sign, we need to force another root. Perhaps let's just modify this. This is going to be 8, positive 8. Right, now we need to think. For these roots to have positive signs, we know that one is going to be positive, one is going to be negative. Okay, all right, okay. Now I'm trying to think which one is most likely going to be negative. Yeah, this one is crazy, ne? Anyway, let's just say we want this whole shenanigan to be positive. Just gonna say 8 plus or minus the square root because I'm unable to decide which one must be 16k. So maths is maths, guys. So you will see that sometimes you got to be skilled. So I'm saying this whole shenanigan must be greater than 0. Whatever this is, both of them must be greater than 0. So what do we do? This is over 1. Now once we know the sign of one of these denominators, we are allowed to cross multiply with inequalities because they will not affect the inequality. So the first thing that we see here is that we're going to have 8 plus or minus the square root 16k minus 24 greater than 4 times 0 is just 0. Right, we transpose that 8, so we get plus or minus the square root of 16k minus 24 greater than minus 8. And then we square this thing. When we square, the inequality is not affected. So 16k minus 24 is greater than 64. Right, we move everything. So 16k is greater than, we move the 24. Let's see, 64 plus 24. I think is of fail, 88. And it 26 get Hagirat, because it's lying. It's lying. It's actually lying. Anyway, let's see. We're gonna get k is greater than 88 divided by 16. It's 11 over 2. But do you see, my inequality is what is betraying me here now. My inequality is betraying me. But anyway, who said it has to be greater than 0? Because this thing said just the same sign. I think this is where the problem is. So if we say same sign, we don't get a perfect answer, ne? Because here I lied. Nobody said this should be the condition, you know? No one said so. All we knew is that we wanted them to be the same sign, okay? So obviously, guys, at this stage, you can see that the algebraic process becomes a little bit imperfect for the second one because it's a bit cumbersome now. We end up with problems because are we going to make them both negative or both positive? Only Jesus can judge here. But you can already see, though, that our main values, even though the answers are imperfect, but the main values, the critical values, came up. Now it was a matter of how do we correct this inequality? Go and ask your teachers, bafethu, ukuthi sizoyithini le nqoba kaxaka. Sikwangqingetshe pha. Ibonile nawe le ndaba. But anyway, guys, this is just to showcase to you some things that you can do that can bring you close to the answers. Mind you, for the last answer, for example, if you're scoring 3 marks, you're just going to lose 1 mark only. I mean, you still have above 50% of this question, so please pass the question. Don't fail just because you didn't get a perfect answer. But you can see some processes are incomplete if you look at them somehow. All right, determine the values of d for which the graph I can dig. You can tell me hey, the values of d for which the graph of p of x is equal to dx plus 9 will be a tangent to n. Holy cross. Okay, P of X. Do we have any P of X here? No, we don't. Yikes. Okay, determine the values of D for which the graph of P of X is equal to D of X plus 9 will be a tangent to N. I can go. 5 marks. Oh bafethu ngula higher grade uyasiqhela kodwa ke sizamhlanganisa ngealgebra. Yabona le, it's an algebra packed dons. Nature of roots. Do you know mos a tangent has equal roots with the parabola here? Secondly, as they have equal roots, they share a point. Okay, maybe let's just say they have equal roots. I think that's what is going to help us here. And if they have equal roots, it means the two graphs equated together will have the same root. So what we're going to do here, we're going to say, fine, we understand that n of x is equal to p of x at the point of tangency. Right? So this implies that 2x squared plus 8x plus 11 is going to be equal to dx plus 9. We write it in standard form: 2x squared minus 8x minus dx plus 11 minus 9 equal to 0. We've got 2x squared minus, we can factor out the negative. When we do that, we get 8 plus d into x. 11 minus 9 is 2 equal to 0. And then let's have a look. We know that this quadratic now will have equal roots. You can just say for equal roots, we know that the discriminant must be equal to 0. Right. And then let's go for it. But what do they say for which values? I'm not happy with this one. Should it be values or a value? It can only be a value, man. Come on. For a parabola, there's only one point of tangents with a particular straight line. It can't be two, so it should have been value or values. Put the S in brackets so that the student sweats. Anyway, whatever. B is our friend here now. Minus this thing. 8 plus D all squared minus 4 into 2 equal to 0. This squared is basically 8 plus d squared minus, this is 4 by 2, that's 8 by 2, that's 16, equal to 0. We fall, this is 64, plus 8 times d times 2, that's 16d, plus d squared minus 16 equal to 0. Write in standard form. Yeah, now I understand the values business. We get d squared plus 16d plus 64 minus 16, that's 48, right? Equal to 0. Aye. 64 minus 16, 48. It's 48, man, it's 48. So what number can add up to 16 but give me 48? Is 12 times 4. Is it 12 times 4? Yes, of course. So we can factorize. So this is D, this is D, this is plus 12 plus 4. Yeah. Sishayile. So therefore D should be equal to minus 4, or D should be equal to minus 12. Now these are indeed true because a negative gradient here of this nature or that nature, any negative gradient could intersect here as a tangent or intersect there as a tangent. All right, so nice and easy, guys. So this one is unfortunately an algebraic thing. We can't do otherwise, unfortunately. So there's these low-key questions which are problematic. So we know that these two are equal. That means they have equal roots. But now we use the discriminant for the business, that the substitution, the two values, 1, 2, 3, 4, 5. Easy peasy lemon squeezy. Erikitlo squeeze man. Squeeze saka. Awatle ku squeeze nyana. Hey guys, ningamameli nivala indlebe lo bhuti uyalibala uthetha noma ncane. Anyway, the gateway arc, is it arc or is it arch? All right, folks, so let's see. Is it an arch or is it an arc? Well, we were told pronunciation has no master, so whatever. Whatever. That's a talk of ignorance, although. Okay, in St. Louis, is it St. Louis? Yes, it's St. Louis, not Louis. It's Louis. It's Louis. Is the shape of a parabola. What is a parabola, my friend? It is the thing that does the things. Okay, this is the parabola. The maximum height of the arch is 192 meters. So this means from the foot to the maximum tones. But the sketch is a bit crazy anyway. Right, anyway, this is an approximation, right? So the gateway arc in St. Louis is shown below. So this is our parabola there. The diagram below shows the arc placed on a Cartesian plane, right? The turning point of the arc lies on the y-axis. So this means this is the standard parabola. That is only going to tell us that the y-intercept is exactly the maximum value. So what is it? 192 meters. So we know that this is 192. Okay, so we're told here minus 20 is to 183 over 2. Sorry, 183 and 2/3 is a point on the arc. Okay, so there it is. Cool. Now the question says, prove that the width of the arc is the same as the maximum height. Show all this one. So what's the width of the arc? This one. The distance between the x-intercepts. So it means we need to find out who is you, and do the things. Now remember, this is just given a parabola with the turning point and an extra point. So nice and easy. So the first thing, we need to find the equation. From the equation, we then solve for the x-intercepts. Simple as that. After that, we take the difference between the two. Right, so we know that this means that the parabola, we can just say let the parabola be defined by, we can just say let the parabola be f of x, such that f of x is equal to, this is a into, it's already a grumpy face thing in Dondons. So this is going to be a into x minus p all squared plus q. So our f of x is going to be a into x. What is the value? Is just like this. The vertex form for this one is just ax squared minus or plus q. Simple as this. This is the grade 10 parabola. So f of x is equal to ax squared plus, what is q? That's the y value at the turning point, 192. Sharp. Sikrand, sikbambile, sigcwele, siyakuncanywa. Next thing, substitute the point. So through this minus 20 is to 183 and 2/3. What do we know? 183 and 2/3 is going to be equal to a into minus 20 squared plus 192. And we can say therefore a is apha sesiyabaleka kuyasheshwa la if awuyazi into yenzayo sengxakini. How do you convert a mixed fraction? If awuyazi sengxakini, so zothi 3 times 183 ikunike answer 549. You add the 2 plus 2, then it is 551. You then divide by 3, so this is 551 over 3 ne? Then la 551 over 3 bese sithini subtract 192, say minus 192 isinikeze so akwazeki nje soze khathi sibone konje sithenga 551 sendiyibhudile 3 times 183 it's 549 plus 2, 551 divided by 3. Okay, that's the one. Next, we then subtract 192. Okay, good. Gives us a negative answer, which we divide by 20 squared. So this one gives us an a value of, at least it's nice, minus 1 over 48. So this is 1/48. Very small number. But you can see that this thing is wide. When it is like this wide, it tells us that this factor, the scaling factor, whatever you call it, stretch, is it the horizontal stretch? I was sleeping. Yeah, this is the one. Now from here, folks, we know that our f of x is going to be minus 1/48 x squared plus 192. Yabona ke ngoku sesifuneza x intercepts. So this is it ngoku 4x intercepts. Yeah, this one was percussion 2.0. So this is minus 148 sendiniwe ngoku x squared plus 192. So this implies minus 192 is equal to minus 148 x squared. So this implies that x squared is equal to, so I'm taking 192 and divide by 148. Gives me 9,216. This one is a perfect square. Most we say square root answer is 96. So we can say therefore x is going to be plus or minus 96. You know what happened? We took the gap and took the gap. Is it the gap? Copy. Now this means this is minus 96. This is 96. You can say then, the width is going to be equal to x2 minus x1, which is going to be 96 minus into minus 96. Now see this one? 96 times 2 by 2 is exactly 192. Asikakayiqibi masibhale conclusion. Sesithi therefore the width is equal to the maximum height. Asiyitsho laa nto lena inyanzelekile. We can say this one is meters most because that one was meters, so that is the one. Yo guys, an essay type question. Nice stuff. This is how grade 12 should be examined as well. Not this nonsense they are getting as well. They're getting nonsense marks. They grade 10 stuff and then they're telling themselves, you got a distinction in maths. Get out of here. You are insulting us. You know, the likes of us who know the things. You are insulting us if you're saying you got a distinction and you're doing grade 10 things in grade 12. Get out of here before I slap you. I'll slap you almost. You know most. I don't play. I don't play with the boys. All right, folks. Again, have a structure. You see, if you're a math student, sometimes even if you botch this, if you start having a bit of a structure, name things so that you can do things with it. First thing, I would give a mark. Remember, this is just a consideration. If you fluff this question, I would give you an extra mark for just having a structure. Second, substituting this one, good. Third, getting the value of A here, or probably writing the equation here, 3 marks. Second is this x-intercept, 4, and then 5 is this one. You count 1, 2, 3, 4, 5. Hlangene. This one is good in that we got a proof. So we already know that if we got 192, we mastered it. So folks, this would have been your total marks, 400 marks in this exam. Obviously, I went a little bit over 2 hours because I'm explaining, right? Remember, in the exam, you are not on a discovery expedition, okay, where you take time and look at things. No, you don't. In the exam, you are on a performance spree. It's all about time factor. And remember, you don't do time attack if your knowledge is poor, okay? So all you do, you strategize, you answer as best as possible and those that you can. But if you are confident, you start with the hard ones so that they are out of the way and then you can sprint on the easy questions. And please, folks, learn the trade to become good. Don't learn to cram so that, you guys believe in cramming and wasting your time. Yeah, well, to some extent it does help. I mean, I had a wake-up call myself. I hated cramming. But when I did pharmacology in 3rd year medical school, I had to cram the damn things because the bloody names of these drugs have no sense whatsoever. And there are so many. And the names sometimes are similar, but they are not in the same class. Yeah, there I had a situation with cramming, and since I couldn't, it became a problem for me. But not a problem that I could not solve, I'm flexible in life, guys, so I'm not saying don't cram totally, but let cramming be your last resort, okay, for a situation where you cannot do otherwise. But at the same time, I just made sure I study for understanding. As much as I had a bit of a situation remembering these drug names, but at the same time, the more you repeat stuff with understanding, the easier it settles in your brain, because in no time I was doing the things, okay? So in no time things were happening. But yeah, it wasn't nice at first. I almost failed my first test. Yeah, that was not good. Anyway, guys, have a good one. Leave a thumbs up, leave a comment, ask a question either on this or something else. Otherwise, keep learning. I will see you next time. Goodbye.